Good afternoon. How are you? So very good afternoon to you, Brish Rishan. Okay. So have you already filled the JMean application form? Mm-hmm. Okay, very good. Okay. So we will just wait for 1 minute more. Let the others to be join. Make sure the screen is visible to you and I'm audible to you. Is it so? Okay. And thank you so much for the response. Okay. Okay. Uh, since you have already filled the JEE main application form, so just to let you know, or you can let know your friends that haven't filled the application form yet. The last date of filling the JEE main application form, let me just tell you. Uh, so for January session, for Jan session, the Jan session for JEE main exam. Okay, JEE main exam. The last date to register yourself, last date for registration, last date of registration is 12th of June. So this is the last date of form filling, and make sure you all who is attending the session and all of the friends of yours that is not yet attending the session but they still attend the session, like Pratibha Chauhan, B. Shrishant, and just a second, who is the another? Yeah, JNV Nizam. So please make sure the last date for filling the JEE main application form is 12th of January, and it is for the January session. Huh? The exam which held to be before the April one. Okay. So this is the last date. So make sure you each and every one of you will uh, fill this form. Okay. And do attempt this exam. Teach you a lot. Okay. So hi Pratibha, how are you? Make sure the screen is visible to everyone who is joining after session. Is the screen is visible to you, Pratibha and JNU Nizamuddin, and my voice is audible to you, so that we can start the lecture then. Okay. As Sridhant has already responded that screen is visible, and Pratibha has also okay. So all of you, the screen is visible and I'm audible. Thank you so much for the confirmation. So here we are with our lecture number 6 of semiconductor. Okay. This semiconductor hardly take 2 to 3 lectures it will take. Okay. As I have already told you about the last date for filling up the JEE main application form, which is 12th of Jan. Please make sure that each and every one of you will fill this form and attempt this examination. Instead of taking physics, chemistry, and mathematics into account, this exam will teach you a lot. Okay, about the competition that you are facing, that you will face. Okay, how to, what is the stress management, what is time management. So each and every concept of the exam uh, will be in front of you when you give this exam. Okay, so all of you, please do register yourself for filling up this email. Okay, so here we are with our lecture number 6 in semiconductor. Now in this series we have covered 5 lectures, and the semiconductor will hardly take 1 or 2 or 3 lectures. most of. Okay, that is it for the semiconductor. Now, so today we are going to learn about some special purpose PN junction diode. In the previous lecture, what we have did, we have see that how the PN junction will be formed, how the PN junction would form, and what are the essential concept that is that participate in building the this PN junction uh, and depletion layer. What is depletion layer? What is depletion width? What is barrier potential? How does it act? Okay, how does it affect the uh, conventional current? Okay, and after that we have learned about some forward biasing condition and reverse biasing condition of diode, and then after we have learned about some characteristic of the this diode. Okay, like the breakdown voltage, knee voltage. So what are those? That all we have studied till now. So today we are with the special purpose PN junction diode. We have so the learning objective. I'm not saying that this would be cover for today. Okay. So this is what we have to learn under this heading. Okay. The special purpose PN junction diode. So in this, we have to learn about the rectifier. What is a rectifier? So PN junction diode is working as a rectifier. Firstly, you will have to understand what a rectifier is. Okay. Then we will learn about that what a Zener diode is, how the PN junction diode will act as a Zener diode. Then PN junction diode is photodiode. This photodiode is nothing but the you will see that it is a kind of photoreceptor which accept the photoelectrons, which accept the electric light from the sun or from any source, and it will act as a diode. It will act as a digital switch. Got it? PN junction diode is light emitting diode. The LEDs that you are well aware of. Okay. LED we use in our households for daily uses. Okay, for lighting purposes. So LEDs that you are must aware of. So this LED is nothing but the light emitting diodes. These are all diodes, na PN junction diode. And then we will see that PN junction diode as a solar cell. Okay. Now, for the rectifier, we will firstly we will recall some concept from the previous topic that we have learned. So in the previous topic, we have learned that how the PN junction will form, how this forward biasing condition and reverse biasing condition will take place. So suppose this is a diode. This is the electronic representation of diode. This part is the positive one. This end is the negative one. Okay. So for forward biasing, if suppose you have a battery, you connect this diode, the positive terminal of this diode to the positive plate of the battery, negative terminal of the diode with the negative terminal of the battery. In this condition, the current will flow. In this condition, current will flow. The current will flow. Okay. So this condition is termed as the forward biasing. Forward biasing. And if you connect this diode, just reverse it with. If you just reverse the diode, the direction of the diode, and keep the battery as same, so what will happen? You have connected the positive terminal of the battery to the negative terminal of the diode, and positive terminal of the battery to the negative terminal of the diode. So in this condition, there are opposite polarities are connected to each other. You can see here, this is negative, this is positive, this is positive, this is negative. So in this condition, the current will not flow. Current will not flow, which means the circuit is off. Okay. Circuit is off means there is no such current would be flow from this circuit. In this, the diode is connected in such a manner that the positive end of the diode is connected to the negative terminal of the battery, and the negative end of the battery is connected to the positive. Got it? So this condition is termed as the reverse biasing condition. Okay? Just opposite to the forward biasing, it is termed as the reverse biasing. I hope you all got this. Okay. So this is what we have did in the previous class. Although one more concept that I want to tell you is the characteristics of diode. Okay. What are the characteristics? So if you draw the potential versus current graph, and in forward biasing, if you increase the value of, just a second, you take the this horizontal axis as voltage and vertical axis as the current. So in this, if you increase the value of voltage slightly, the current will increase up to a certain level, which is known as knee voltage. Knee voltage, you have to provide each and every diode, so that after the knee voltage, if you provide further, if you increase the voltage, the current will shoot up immediately. Okay? But up to this point, the value of current will flow, but it is very less. You can see here. Okay. But after this point, it will flow abruptly. It will increase abruptly. Okay. So this voltage, after that, the current will shoot up in forward biasing. It's termed as the reverse, oh sorry, is termed as knee voltage or cut-in voltage. Cut-in voltage. Okay. Now, but what happens for the reverse biasing? If you just change the polarity of the battery, the diode will act as a reverse bias diode. Okay? In the reverse biasing, if you increase the value of potential, the current will not increase, which means there is no net value of current. Okay. But after a point, the current will immediately shoot up. In fact, it shoot up rapidly than the forward biasing current. Okay. So this point, yeah, this voltage is termed as, after that, the current will shoot up in reverse biasing also, is termed as the VBR. And VBR is nothing but the breakdown voltage. Breakdown voltage. This breakdown voltage tells us that after the value that you have provided, if this increases the value, yeah, it compete with the value of breakdown voltage, then the diode will not work, because the heavy amount of current will flow through the diode, which will destroy it. Okay. Got it? So it is mentioned by the manufacturer of the diode that what kind of, in the reverse biasing, what will be the value of this VBR. Okay. Forward biasing, the knee voltage that we need, because we need to flow the current in forward biasing, but not in reverse biasing. Why? Because the current in reverse biasing that is flown through the diode is not dependent on the voltage that you are providing. It depends on the temperature. But what does this voltage do? It increases the value of temperature. Okay. So when this current shoot up, the heat provided in the circuit will also shoot up. So the heat is equals to I square RT. This is the heat generated by the system when current I is provided. If the current value is large, the heat value will be so large because it is the square of the current. So there is so much heat in the system that is not bearable, that is not, the diode is not able to hold that heat. All the covalent bond present inside the PN junction will break down, so the diode will collapse or destroy. Okay, so we have to take care about this VBR. Okay, after this VBR, if you increases the value of voltage, the current value will definitely shoot up. Okay, but it is not dependent on the voltage provided in the reverse biasing. Okay, so in reverse biasing, the current flow, this is, which is known as the reverse bias flow current, okay, is not dependent on the voltage that you have provided. Okay, I hope everyone got this. Hmm? So a better graph, I will tell you. So this is current, this is voltage. In forward biasing, you are providing positive value of voltage. So I'm writing it here. Initially, the current will be negligible, very small. After the knee voltage, it will shoot up. Okay. This value is termed as V naught, which is knee voltage. But in the reverse biasing condition, the current will be negligible, and after the breakdown voltage, it will just shoot up. This point is known as VBR, the breakdown voltage. Okay. Now, so this is all about the recall part that we have did previously. Now we are in the PN junction diode as rectifier. How this PN junction diode is acting as a rectifier, and what does a rectifier is? Firstly, we need to understand this term. Okay, what does a rectifier is? So before that, I would uh, I would want to introduce you the concept of AC and DC. Many of you have the idea about what is AC and DC. It is alternating current and direct current. And the rectifier is a kind of device which is used to convert this AC into DC. Okay. So that is why it is important to learn about the AC and DC here. Okay. Although you have covered it in alternating current chapter, so I do not need much details to tell you, only the fewer one. Okay. So for AC, if you talk about for AC, so AC stand for alternating current, alternating current, and DC stand for DC stand for direct current. Okay. What is the difference between AC and DC that we see? For DC, for DC, if you see, this is the value of current, and at a point of time, let this is the time graph. This is the value of time. So this DC will have some value. Let's say I naught at this point of time. At this point of time, it is also having a same value. At this point of time, it also has the same value. At this point of time, it also has the same value. So this direct current, if you connect all the dots, you will see this current as it this. Okay, just a second. So this current would appear to be a straight line, which means this current does not change direction and does not change magnitude. Does not change direction, the DC current I'm talking about, and does not change magnitude. ठीक है, so this is the direct current. ठीक है, Ohm's law is applied to it. V is equals to IR. Increasing the value of current, the voltage will increase. Increasing the value of voltage even. ठीक है, so if we increase the voltage, the current will directly proportional to it. So V is equals to IR is hold good for this, and where R is the resistance of the circuit. Okay. But what if I talk about this AC, alternating current? As the name suggested itself, alternate, the current which alternate itself. ठीक है, जो बदल सकता है खुद को, that is the alternating current. So if I draw the plot of it, this is the value of 5, this is the value of time. So for this time the current will be 0. For this time the current will have some value. At this point of instant it will have some value. Then it will constantly decrease, and then it will decrease to the negative levels of current, and thus and so on. Okay. So if you connect these dots also, you will have a curve like this. Although this is not the specific one, you will see the alternating current by this wave also, but this is the mathematical wave. Okay, that is to be considered for all the derivation purpose for alternating current. Okay, this wave is termed as the sinusoidal wave. Sinusoidal wave. Got it? So this current I here is varying as a, so this current I is using as varying as a sinusoidal wave. Got it? So from here you can say, for this point of time up to this 0 to, let's say, capital T, this point of time the current is positive, this value is positive in the upper side, and in the lower side it is negative. So for 0 to T it will vary, the current is also varying, the magnitude is also varying, but the value of current is positive. But after this point it reaches the value 0. At this point it gain maximum value at this point, then again decreasing but positively, then again it will become 0, but after that it will increases in the negative side, which means current is constant sinusoidally decreasing, and it attains a maximum value in that also. Again it will increase, become 0, and then it will also increase. Okay, so this current does change its magnitude and also this current also does change the direction. Okay, so the alternating current is constantly changing or varyingly changing the direction and the magnitude. Now we have to convert this AC into DC. How is it possible? It is possible because of the rectifier. Now how the rectifier works, let me give you some idea about it. Suppose this is the alternating current wave, and you have to convert it into the direct current. So what you can do, firstly, you do not want this current to change the direction, because if the direction is changed, then it will behave as the alternating current. So the very first condition is that you don't want to be this current to be changed the direction. Okay. So this, the boxes which is in the negative side, you want to disappear that. Okay. You want to delete that. If you able to delete that somehow, then what kind of wave you will have? You will have a wave like this. Got it? This is the modified current and this is the original current. I know. In this scenario, what has happened? You have just deleted the negative side current. Okay? The negative values of current. Only the positive values of current you will have. Okay? Now, what happens if the frequency of the current is too high? Frequency of the current is, what is the frequency? When a wave repeat itself after a fixed period of time, when a wave repeat itself after a fixed period of time, that is told to be the frequency. Okay, got it? When the wave repeat its pattern, let's say frequency is given as 60 hertz, okay, which means 60 times in one period of revolution, the wave changing its pattern. Okay. Now, if you closely look here, this wave is changing its pattern. This is also the part of this wave. After this and this, it will again repeating itself. Again repeating itself. है ना? What if, so this is the time period. Let's say this is the time period for one revolution. है ना? And frequency is defined as how many revolution in one time period it has completed. Okay. If I decrease this time period, this value, this gap, and if I take it closer to the one another, then what will you have? You will have a pattern like this. You know? And if you take the RMS of this, which is root mean square, if you take the root mean square value, this current, this variation of current, you will have a line which is exactly at somehow below to this point and will be a straight line. So this line represents the RMS value of current. Now, instead of drawing these graphs, you will have a graph like this, which is similar to the DC, direct current. So we have converted this this alternating current into the direct current. And it is possible because of the rectifier. Okay. Now, how the rectifier works in this? We understand our purpose that we have to delete this negative portion of the current. Okay. Now, what if I tell you, just a second, huh? Till now, if you have any kind of doubt, you can ask. Any part that is not getting into your mind, you can ask in the chat box. Now, this is a diode. Okay, this is positive, this is negative. If you connect it with the alternating source, this is the symbol of alternating current. Okay, if you connect it to the alternating source and you draw the variation of current with respect to time, and also here there is a resistance which is RL, load resistance. Okay. So what happens? This source will provide a value of current which is alternating in nature. So I am drawing this current. This is the, let's say, this is the input current that this source is providing. And let's say this is the output current that is we receiving at the load resistance. Okay, after passing through this diode. So this is the output current IO and this is II. This is output current. Okay. Now this source is sending these pulses like this. So for this value, this positive value, this point is behave as the positive side. This point behave as the negative side. Okay. For the positive value of current. Got it? So the positive terminal is connected to the positive end of the diode. Negative terminal is connected to the negative end of the diode. So current will be forward bias. So this is the condition for forward bias. So diode will allow this current. The diode will allow this current. Okay. The diode has allowed it this. But we know that this alternating current source change its polarity with time. है ना? After a fixed period of time, it will change its polarity, as you can see here. At this point, the current will become zero, and after that, it is changing its polarity. It become negative from positive. है ना? So if it is changing its polarity, which means this source is also changing its polarity because this is the source who is providing this alternating current. So after that positive cycle, this source change its polarity, which means this end now will act as negative side or negative terminal, and this source, this point will act as the positive terminal because it just reverses the direction of current from positive to negative. So here you can see that this positive end is now connected to the negative end for the negative cycle. I am writing it here for positive cycle of current. Diode will be forward bias, and for negative cycle of the current, diode will be reverse bias. Okay, so this positive terminal is connected to the positive terminal of the diode for the negative cycle is connected to the negative side of the alternating source, which is the condition for reverse biasing. Opposite polarities are connected to each other, which means now the diode will act as a reverse bias. Okay. And in reverse bias, there is no current will flow through the circuit because in reverse bias, the diode will act as a resistance, a much higher resistance to the current. Okay. So that it will not allow the current for this negative cycle. The value of current, output current will be zero for exactly the time for which the negative cycle is going on. Okay? And in due to the repetition of this, you will have the same cycle. And this is the same cycle that we have seen so far. In this scenario, in this device, we have deleted the negative side. So we have accomplished our task because we have deleted the negative side of current or the negative values of current in the output current. Okay? With the help of this device. And this device is termed as the rectifier. Rectifier. And more specifically, this is termed as the half wave rectifier because it is only able to rectify this half wave, not the full wave. Okay? Now, make it more understandable to you. The process of converting the alternating current into direct current is termed as rectification. Okay? What does it call? It is called rectification. And the device which is doing this task is termed as rectifier. Is rectifier. The device used for the rectification is called rectifier. Now, PN junction diode offers low resistance. I have told you everything. The PN junction diode offers low resistance in forward bias because it allows the current to be flow, and a very high resistance in reverse bias. This property is used in rectifier. Okay. So now the PN junction diode has half wave rectifier. Let's just see the construction of it. So these are the primary coil and secondary coil. Okay. These are, you do not have to confuse with it because it is a very detailed picture because current is not coming directly to the diode. It is coming through the transformer that we have used, and in transformer we have primary and secondary coil. Okay. So it is showing that this source of current is alternating. This is alternating source. Okay. Now, this is the load resistance represented by RL, and these are the ends from which we are getting the value of current. Okay. So for forward biasing, you can see here, this is the positive side and this is the negative side. Okay. In this condition, if you will see, in this condition, the polarity will change. Here it is plus and here it is minus. So positive end of the source is connected to the positive terminal of diode. Negative end of the source is connected to the negative terminal of the diode. So it is allowing the only the positive side, not the negative one. For the negative side, no output you will have because now this is the complete cycle. This and this green dot, I have shown here it separately. This is for the positive cycle. So for forward biasing condition, this diode is allowing the forward bias, allowing the all current which is in forward bias. Okay. But for reverse biasing condition, when the polarity has been changed, so this positive side of the diode is connected to the negative side of the source. This negative side of the diode is connected to the positive side of the diode. Okay. So in this condition, the diode will be reverse biased because opposite polarities are connected to each other. And we are providing this because of this cycle, because of the negative cycle, this change in polarities happen. Okay. So for that, the diode is reverse bias. This is reverse biasing. So no output you will have. So zero line you will have. And in this condition, the diode is forward bias. Okay. Now, If you will see the complete cycle, the amination you will see again, you will see it again. Here the alternating current is going on from the source, and here you will have the output current. This is output current, and this is the input current. Okay, got it? Again you will see the amination of it. The input current is completing its cycle from positive to negative, but output current you will have only the positive side. The negative side of the current is rectified by this diode. So this system, this device is termed as the rectifier. And which kind of rectifier? Half wave rectifier, because it is rectifying only the half wave of the alternating source. So you can write it here. This device, this device is rectifying only the half wave of the alternating source. Okay, or you can say alternating current itself. So that is why it is termed as half wave rectifier. Okay. Now we will deal with the p-n junction diode as full wave rectifier. Okay. So for full wave rectifier, nothing. What you can do? You can do just you can add. Let me just show you. For reverse biasing condition, sorry. So this is the half wave rectifier. This is set up for half wave rectifier. Got it? What if this is half wave? This is half wave rectifier. Okay. But what if this is this alternating source and this is providing a value of current like this? Now you can see this is the positive side of the diode, this is the negative side. So for this cycle, this negative cycle, when this alternating source changes its polarity, it will become negative and it will become positive. Now, what if I connect the another diode but in opposite in direction? And let me draw it here. This is the original setup. Okay. And one more source I have connected to it. Just a second. This is the original setup you have. Or in the same manner we will draw. Not to confuse you. In the same manner we will draw it. Like this. And these two diodes are connected to this alternating source. Now what will happen for this positive cycle? This end is positive, this end is negative. Okay. So, and this end is negative, this is positive, this is positive, this is negative. So for this arrangement, for this positive cycle, this end is positive for the alternating source, which is connected to the negative end of this diode number 2. This is diode number 1. So this positive terminal is connected to the negative terminal of diode number 2. This positive terminal is connected to the negative terminal of the alternating source, which means this diode, in this condition, this diode is reverse bias because opposite polarities are connected. But for diode number one, the positive side is connected to positive side, negative side is connected to negative side. So this diode would be saying forward bias. So for output value of current, this is input, and this is output. So for output value of current, the positive cycle will be regained by this, because it is allowing this current to be flow through it. Okay. So what will happen, and uh, if there is a load resistance here, like this is the load resistance we have add some load resistance to it, so the circuit will complete now. Okay. Now, so for this condition also, positive side will be rectified by this. Okay. So it is in reverse bias, diode number two, but diode number one is in forward bias. So it will allow this current to be flow in the circuit. So this is the output current, positive side you will have. What if for the negative side? For negative side, this source will change its polarity from negative to positive. Now, if you will see, this negative side of diode number two is connected to the negative side. This positive side of this diode is connected to the positive side of this alternating source. So this, the same polarities are connected. So now this diode number two will act in forward bias. But for diode number one, you will see that opposite polarities are connected to each other. Okay? Which means this diode number one in reverse bias for this negative cycle. So it will not allow this current, but diode number two can allow this current, because diode number two in forward bias. Okay? So it will allow this current to be the positive side, like this. This is the value of current passing through this. Okay? So in forward biasing, it is also allowing this current. Now, same again, if this changes its polarity, you will have this from diode number one. Again, if will change its polarity, you will have this from diode number two. So you will have a full wave is rectified. You will see the full wave is rectified, not terminated the negative side. The full wave is rectified now. So this setup is termed as the full wave, full wave rectifier. Okay, got it? Now, for your better understanding, this is the setup for full wave rectifier. So when the diode rectifies the whole AC wave, the negative and positive both sides, it is called a full wave rectifier. Here you will see this is the source you have. Suppose this source initially it has positive side this, and this is the negative side. So this diode you will see the positive end is connected to the positive one, so it is forward bias. It will allow the current, the positive side. But when it changes its polarity from positive to negative, so this diode will act as the forward bias, the diode number two. Now, this is the final value of the alternating current. The negative cycle of the current is rectified by this D2, the another diode that we have used. Okay, got it? If you will see, so during the positive half cycle, the input AC signal, the diode D1 conduct the current through BA. Okay? For this positive cycle, I have already talked about it. So current will flow in this direction from B to A. Now, during the negative half cycle, the diode D2 conducts the current, and current is through BA again. If this is the flow of current, so B to A will flow. The same value of current is there. That is why this graph is obtained all the positive values, all the values of this rectified wave is positive because both the diode allowing the current in same direction from B to A. Okay. Now the rectifier with filter circuit, you will see this is the rectifier that we have used. This is the incoming AC, the input AC that we have provided to the circuit, and this is the variable DC. This is also variable. Why it is DC? Because it is not changing its direction with time. Why it is not complete DC? Because it changes its magnitude. So that is why it is a variable DC. Okay. So when the voltage across the capacitor is rising, it gets charged. So जैसे ही ये current को allow करेगा, the full wave rectifier we have used, so the current will stored across the plate of this capacitor, which is Q is equals to CV. Okay. And this get charged. Now, if there is no external load, it remains charged to the peak voltage of the rectified input. Okay. Because there is no connection to discharging it. There is no load connected to it. So this will remain charged. Okay. Now, if the load resistance is connected to it, when there is a load, it gets discharged through the load and the voltage across it begins to fall and the cycle start to repeat. So when this capacitor is connected to the load, it is charged by this rectifier. Rectifier charge this circuit, which is the capacitor. When we collect the load to it, it will discharge along the this load. Okay. So this load resistance will use this charge as a flow of current. Okay. Now the output voltage, please focus on this point. The output voltage obtained by using capacitor input filter is nearer to the peak voltage of the rectified voltage. So this type of filter is most widely used in power supply. Okay. Before the rectification, the current is alternating source. After rectification, it will become DC, but the variable one. When we have used a filter, and what is this filter? This filter is the capacitor. And then we use the load current and we measure the output value of current in there. So the current provided by this capacitor until charging will be the peak value provided by this rectifier for the entire cycle. Okay. And you have known that the capacitor instantly uses its value for charge. ठीक है, instantly discharge हो जाता है this capacitor. ठीक है, approximately 70% of its current. ठीक है, so that is why you having a nearer to constant value of the power supplies. ठीक है, got it. So this is it for today. In the next lecture, we will see the further application of semiconductor diode. Till now, if you have any kind of doubt, you can ask in the chat box. Otherwise, the lecture is been over. Thank you so much for being attentive. Okay. Thank you so much. Take care of yourself. Bye-bye.